Section 4 deals with the properties of logs. Now once we learned what they look like, how the graphs look like, and how to transform and move them left and right. Now we're going to learn how to manipulate them. And we have a series like 3 or 4 rules. The first rule, the product rule. Remember, product means to multiply, which means you make things bigger. And here's the logarithmic rule here. So it's log. Instead of putting it on a base, so let's leave it log. Well, okay. M times n. As long as you have the log of a product of numbers or elements, you can expand them by adding them together. Oop, n. So take the log of this one and log. It's kind of like distributing, but we have to add them together. So let's take this example. The log base 3 of 9 times 27. So we can, since it's product, we can split them up. Log base 3 of 9 plus the log base 3 of 27. Let's go ahead and solve these. So remember, we had log base 3 of 9 is equal to x. So that becomes 3x equals to 9. 9 is 3 times 3. So x equals 2. So this first one equals 2. Then log base 3 of 27 equals some number x. 3 to the power x equals 27. 27 is made up of 9 times 3, and 9 is 3 times 3, so it's 3 times 3 times 3. Same bases, x equals 3. So that one equals 5. Let's look at example 2. We can work backwards. Log base 2 of p cubed plus log base 2 of q. No, first off, you have to make sure the same base. The same bases, since they're added together, I could put them together by the product rule. And there's the answer. You have to be able to remember, you can go both directions with them. All right, the next one. The power rule. The power rule says this, and this is a general rule with all logarithms. You cannot have exponents, or you're not supposed to. So if you have an exponent, they come in front. So there's that property. Here's that property. Example 3. Example 3 here is log base a of 11 to the power negative 3. There's an exponent, so bring it out in front. So it's negative 3 log base a of 11. Next one is log base A of the fourth root of 7. For this one, we have to remember this rule. The number inside that v is called a root. And we can convert this radical, whatever's inside that goes on the bottom of the exponent. Whatever's inside goes on top. So we have this rule. So the first step we have to do is convert it to an exponent. So the power of 7 inside here is 1, so it's 1 divided by 4. That's an exponent, comes in front, so it's 1/4 log A of 7. Then C, you have sorry, ln x to the power 6. That's an exponent, comes in front, so it's 6 ln x, and that's it. That's all you can do. All right. Let's look at the next property. Since we did the power rule, the product rule, let's go backward. Let's do the quotient, the fraction. Quotient rule says this. If you have a log base A of a rational equation, because fractions make things smaller, we can split these up. Log base A of m minus log base A of n. Actually, this rule is made up of the other two rules. And I'll show you. Log base A of m divided by n. I can rewrite that as log base of m. To bring this n on top, all I have to do is just change its exponent. So that's the first thing I do. Instead of making a fraction, I can put them up like this. It's a product, so I can use the product rule. M plus the log n to the power -1. Can't have exponents, so that comes in front of that one. So we have log base A of m. And bring negative, so negative positive is negative log base A of n. So it's not really its own rule. It's a combination of the two other rules. So an example 4. Log of t 8 over w. It's the same base, so we're a fraction, so it's log base t of the top number minus log base t of the bottom number. And there's your answer. Let's look at going backwards now. What if I gave you this equation? Log base b of 64 minus log base b of 16. And this is also going to show you a logical reason for using this method. They're both log base b. That is the first condition. Has to be true since they're the same condition. So since they're both the same, I could pretty much factor that out. If it has a positive coefficient, it goes on top. If it has a negative, that number goes on the bottom. So now we can simplify this. 64 divided by 16 is 4. So it's just one way we could simplify our equations. Common errors to avoid. This is not the same as multiplying the two. Since you're multiplying them, we have to add them together. All right. So if we had a combination log of m plus n, we cannot do that. We cannot split those up. Why? Because log of a of m plus log of a of n, when you add those together, that's the product rule. This is not the product rule, so you can't do that. The most common mistakes people do also, log base a of m over n, do not split the logs for both of those. You can't do that. And also a common error is if your function is inside a parenthesis raised to a power, you cannot bring the power out of that in front of that parenthesis. It's only the power of that term itself, not the whole equation. All right, so those are the most common ones you have to avoid. All right, so here's an example. Let's look at these. Example 6. A. We're going to use these properties and expand these rules, these examples. X squared, y to the 5th, z fourth. I'm going to do it 2 ways. I'm going to do it one way. You're going to use the rules, and then I'll show you a shortcut. So that is one equation with a log. So since it's divided, we can look at it 2 ways. So it's 2 equations. We have the top equations minus the bottom equation. That's what the fraction means. In the first one, we have a multiplication, so we can split those up. Log base a of x squared plus log base a of y to the 5th minus log base a of z to the 4th. You can't have exponents. 2 log base a of x plus 5 log base a of y, 4 log base a of z. And there you have it. And remember, we also go backwards. And that's what we're going to do next. Let's look at this. If I gave you this, and you have to work backwards. Remember, if you have a coefficient, don't worry about the sign, just the number in front. Those will come up on top. Then, if you have different signs, whatever the ones that, since they're all log base a's, that has to be log base a. That goes out in front. Whatever has a plus in front of it, positive in front of it, those terms go on top. If it's got a minus, those go on the bottom. That's the shortest way you can do these. So we have log base A of cube root A squared B over C to the fifth. Yes. So first we're going to do is get rid of that radical. So the radical, since it's a 3, it becomes a 1/3 power. So we have A squared B C to the fifth. Now, since it's a power and a bunch of equations inside there, we can distribute that power to everybody inside there. And remember, it's power to a power you multiply. So we have 2 times 1 over 3 is 2 over 3. This is a 1. 1 times 1/3 is 1/3. 5/3 times 1 over 3 is 5 over 3. No. Okay, so we got rid of the parentheses and everything. Now we spread them out. So we have log base A. On top, we have A to the power 2/3, B to the power 1/3, minus log base A to the C to the 5/3. And since this is a product, we can split them up. We also could, since we saw this as multiply together, we could have split them up. We could have split them up back there. But since it's a product, we have to add them. So it's log base A of A to the 2/3 plus log base A of B to the 1/3 minus log base A of C to the 5/3. These are all exponents. They all have to go in front of their respective logs. So it's 2/3 log base A of A plus 1/3 log base A of B minus 5/3 log base A of C. Now, it looks like we're finished, but we're not really done because we can still simplify. Log base A of A is 1, so it's 2/3. And these we don't know, so we just write them out. You have to keep on going as far as you can. All right, let's look at the next example. Example 8. We're given this 5 log base B of X minus log base B of Y plus 1/4 log base B of Z. First check, they all logs the same bases. So since they're all log of the same bases, we do that way. And notice we have coefficients. So this first one becomes x to the 5th minus log base B of Y. This becomes log base B of Z to the power 1/4. They're all log base B's. Since there's pluses and minuses, anything with a plus goes on top. That was a plus, it goes on top. This one's a plus, goes on top. And this is a minus, it goes on the bottom. And the only last thing we can do Since this is a fractional 1/4 exponent, we could make that into a fourth root. And there's our answer. All right, example, that was 8? No, that was example 7. How did I mess up? That was 6. This one should have been example 7. This is 8. So this is example 8. ln 3x plus 1 minus ln 3x squared 5x minus 2. The same ln's, there's a minus, so that means we have ln 3x plus 1, 3x squared minus 5x minus 2. We got to simplify it even further because that's a radical. I mean, it's a quadratic. So we have ln, the top is linear, so leave it alone. We got to factor this one out. Remember, so we take the first term, 3x and 3x. Second sign's a minus, so they're opposite signs. Take these. 3 times 2 is 6. So what times what equals 6? When we subtract them, we get 5. 6 and 1. And since the first term's a minus, the bigger number goes with the minus. Now factor. Nothing factors out of the first one. A 3 factors out of the second. So get rid of that 3. So our denominator looks like this. The 3x plus 1 cancels, so we're left with 1 over x minus 2. And that's our answer. As a single logarithm, here's another way of solving these equations. If I give you predefined values, so example 9. Let's say that log base a of 2 is 0.301 and log of base a of 3 is 0.477. That's all we can use. This is what's given to us. Solve these. First one, log base a of 6. Using this only. What is 6 made up of? Is made up of 2 times 3. Base 8, 2 times 3. It's a product rule, so I have log base a of 2 plus log base a of 3. Hold on, let me get my dog to be quiet here. There. So log base a 2 is 0.301 plus 0.477. Yes, 0.778. So as you can see, our objective here is try to take what we have and use the rules of properties and simplify it. It's a rational expression. So we have log base A of 2 minus log base A of 3. 0.301 minus 0.477. It's going to be zero. It's going to be negative because this one's bigger. So it's going to be 176. C. Log base A of 81. Remember, we can only use 2s and 3s. Well, for 1, we know that 81 is made up of 9 squared. Nine is made up of 3 squared. So that's going to be log base A of 3 to the 4th. The power comes down, so it's 4 times log base A of 3. Log base A of 3 is 0.477 times 4. So it equals 1.908. Log base A of 1/4. It's a rational expression. So we have log of A of 1 minus log A of 4. Log base A of 1 is 0. 4 is made up of 2 squared. So that square comes out in front. So it's negative 2 log base A of 2. Log base A of 2 is 0.301. So it's 0.602 negative. So it's how, using the properties and rules, how can we rewrite what we're given to what we're looking for? And the next one, E. Log base A of 5. The only thing we could do with 5 would be log base A of 2 plus 3. But when there's common mistakes, we can't do that. So this is as far as it goes. We can't do that. Log base A of 3, log base A of 2. Log base A of 3 is 0.477 over 0.301, and whatever this in the calculator equals. So far, so good. We have two more properties. The first one, log base A of A to the power x. Whenever you have the same base and the same base, well, we talked about it first. Same base equals 1. But since we have an exponent that comes out in front, this equals 1, so that equals x. So whenever you have the same bases, those cancel out. You just have whatever the exponent is. Let's look at example 10. So we have log base a of a to the 8th just equals 8. Ln e to the power -1 equals -1. The reason, because ln is equal to log base e. So we have log base e of e to the power -1. Since these are the same, the answer is -1. And C, log of 10 to the 3k is equal to 3k, because this is log base 10, so the power goes out in front. Let's see more examples. Now we have another property. Oh, and this is the first property, the second property. Reverse these. What if we had the base log to the base of x? So if the bases are the same, no matter how you arrange them, it's just with whatever's left. So we have 4 log 4x. Since these are the same bases, the answer is x. E ln 5. Since it's e log base e of 5, the answer is 5. Those are the same bases. 10 log 7t. This is log base 10 of 10. 10 log base 10, so it equals 7t. All right, that's the end of that section.